Hey guys, Mr. Rast here. I just want to start off before we get into this lesson with a correction to something that I had taught you guys earlier. I told you, maybe you recall, that anions are negative. Well, the truth of the matter is they're not really negative, they're just misunderstood. Alright, welcome to Topic 8, Lesson 3, Balancing Equations. I'm Mr. Rast. So, we're going to talk about how to balance equations in this lesson. To do so, I'm just going to go over, basically I sum it up in 4 simple steps. The first thing is we're going to list all the atoms in an equation. So let's just go over the steps and then I'll do some practice with you. I'll show you a couple examples. So first thing is we're going to list all the atoms in the equation, and then we're going to count all the atoms. So all the reactants and all the products of all the atoms. The next thing is we're going to try to balance the atoms one at a time. So we'll try to balance one atom at a time, and then when we do that, we check. After we try to balance it, we check and recount everything to see if everything's balanced. If it's still not balanced, if there's atoms that don't match each other, then we just go back to step 3. We try to balance them again one at a time. If they are balanced, then we're done. So I'm going to talk about these 4 steps, and we're going to do some examples on how to balance chemical equations with this. So we're going to list the atoms, count the atoms, try to balance the atoms one at a time. If they're not balanced, we just go back to step 3 and we try to balance them one at a time. We just keep going and going and going. If they are balanced, we're done. So we're going to balance this equation here. Magnesium plus oxygen makes magnesium oxide. So the first thing that we need to do here is list all the atoms in this equation. So magnesium plus oxygen makes magnesium oxide. So we're going to list them. So the atoms that we have here is magnesium and oxygen. So this is what I mean about the first step, listing all of them. And what I do is right under this yield sign, this arrow, which is called a yield sign, I will list all the atoms. So in this case, there's just 2. If there was 3, I would just keep going down, 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 3, 4, whatever. So I've got them all listed. And the second step was to count them. So I have magnesium. How many magnesiums do I have as reactants? I have only 1. How many oxygen atoms are there on the reactants? There's 2. Where on this side here, I've got 1 magnesium and I've got 1 oxygen. So the 4th step, now that I did this here, I'm going to try to balance them one at a time. And if we look here, magnesium is balanced. There's 1 magnesium on both sides, but the oxygens are not balanced. I need more oxygen on the product side. Again, this side here is reactants. These react to get to yield to produce a product. So I will often refer to the left side as reactants and the right side as products. So the same number of each kind of atom must appear on both sides, and they don't right now. So this is something you need to understand, that when we add values, when we're trying to balance equations, we can only add values in front of the elements or compounds. So all I can do is in front, I could add a value here. I can't add a subscript. A subscript is changing the molecular formula. We know that magnesium is just 1 magnesium. It's elemental magnesium. And what we've learned with diatomic atoms, and go back into older lessons with the, if you're not comfortable, if you don't remember the diatomics, there's 7 diatomic elements, that they don't appear singly as a single. They always appear in pairs, and we call them diatomic, and oxygen is one of those diatomics. So I can't change this value here. You might think, well, I've got too many oxygens here, so let's just get rid of this too. Well, you can't, because oxygen is always paired. And magnesium oxide, we can't add subscripts to the magnesium or the oxygen. You can only add numbers in front of the molecules, because we know magnesium oxide is magnesium has a charge of +2, and oxygen has a charge of -2, so it's a 1-to-1 ratio. I can't change these values because it is a 1-to-1 ratio. If you're struggling with this concept, please go back and review the lesson on ionic compounds. So I can only add in front. So let's take a look here. If I add a 2 in front of the magnesium oxide, trying to balance these oxygens, because I don't have enough oxygen on the right side as the product, if I put a 2 here, that doesn't just change the oxygen, it means that I have 2 magnesium oxides altogether. So I have to reevaluate this and say, now I've got 2 magnesiums and I've also got 2 oxygens. Now that I balance the oxygens, I have unbalanced the magnesiums. It's kind of like solving a Rubik's Cube where you solve one side for its color, and then when you try to solve another side, it ruins the one that you just fixed. But that's okay. We keep working, we keep solving it a bit like a Rubik's Cube. So the oxygens are balanced, but now the magnesiums are not. So what could we do adding only numbers in front? By the way, these numbers in front are called coefficients. What can I do to make the magnesium on the reactant side balance the magnesium on the product side, because the oxygens are good? And you might be noticing right here I could add a value. And so that's what we're going to do. We're going to put a 2 here. So we have 2 magnesiums on this side. And when that happens, I recount. That affects this magnesium here. Now I've got 2. It doesn't affect anything else. And now my magnesiums match. I've got 2 magnesiums on both sides. And my oxygens match. I've got 2 here and 2 here. So that is balancing an equation. That's how we do it. I'm going to give you a little bit more challenging one to do. Let's do this one right here. Let's try to balance this equation here. So let's do those steps again, and I'm going to do this one by hand. So I've got, and by the way, this is a reaction. This right here is the empirical formula, or this is a formula, the formula for ethanol, which is drinking alcohol. And if you have very strong concentration of ethanol, you might be aware that you can light it on fire, it burns. So, but what the reaction is that the ethanol reacts with oxygen to produce carbon dioxide and water. So this is the reaction of burning of ethanol. Let's take a look here and figure out how to balance this equation. So first thing I'm going to do is I'm going to list the atoms. I've got 2 carbon, or I'm sorry, just list, not count. I've got carbon, I've got hydrogen, and I've got oxygen. I've got carbon, hydrogen, and oxygen, and that's the same on both sides. So next thing I want to do is count them. So let's count them up. I have 2 carbons as reactants. I've got 6 hydrogens as reactants, and I've got 1 oxygen and another 2 oxygens. So I've got a total of 3 oxygens on my reactant side. On my product side, I've got 1 carbon, I have 3 oxygens, and I've got 2 hydrogens. Okay, so we're going to try the third step. Remember, there was 4 steps. So I just did the first 2. The first one is list. The second one is count. The third one is let's try to balance this 1 atom at a time. So I don't know, let's try, oh, by the way, I usually will, just a word of suggestion, advice, is something that's alone, like this oxygen, I usually try to balance last, because if it's alone, if I add a number here, a coefficient, it doesn't change anything else. Notice if I add a coefficient here to the ethanol, it's going to change the carbons, the hydrogens, and the oxygens. And just like a Rubik's Cube, this is going to affect 3 things. So I usually try to balance things that are alone last. So the nice enough, the oxygens are balanced right now. But let's try to do this carbon. So I've got 2 on this side. To get a 2 on the other side, if I put a 2 here, that cancels this out. Now I've got 2 carbons, which is nice, but now I've got CO2 twice, so that means I've got 4 oxygens here plus this other oxygen from the water. So now I've got 4 plus 1 is 5. So now I had oxygen good, but now it's no longer good. Now the oxygen's kind of messed up. So I've got 4, 5 oxygens here. Okay, the carbons are good. Let's try the hydrogen. I've got 6 hydrogens here. I've only got 2. To get this to be a 6, if I put a 3 here, now I've got 6 hydrogens, but I've got 3 oxygens plus I've already got 4 over here. So 3 oxygens and another 4, I've just turned this into 7 oxygens. So this oxygen's gotten way out of control here. But let's take a look here. I've got the carbons are good, the hydrogens are good, so now I'm not balanced yet. The oxygens are not equal. I'm going to try to balance the oxygens. So on this side here, I've got an oxygen here, and I have a choice on which one I want to add to try to get to the 7. Well, I wouldn't want to do this coefficient here right now, because that would change my carbons and my hydrogens. So if I want to try to balance this, I'm leaning towards over here. Remember, whatever I put here, it's plus 1. So if I subtract 1, because I got 1 here, from 7, that's 6. So if I put a 3 here, 3 times 2 is 6, plus the other 1 is 7. So that gives you 7 oxygens. So just a quick double check. I've got 2 carbons here and 2 carbons here. I've got 6 hydrogens here, and I've got 3 times 2, 6 hydrogens on this side. I've got 1 and 7 oxygens on this side, and I have 4 plus 3, 7 oxygens on this side. So it's balanced. So this is all you need to do for your answer, is right here. Okay, so I've got some practice problems for you guys to do. Balancing equations, and we'll go over these ones in class. So this is workshop 3 for topic 8. I've got 7 of these that I need you guys to balance, and then we'll go over those in class. Save any questions that you have while you're trying this, anything that you want to go over. Make sure you make us aware of that so I can help you. Good luck, and don't be afraid to ask. That's what I'm here for, to help you guys out.